Hello and welcome to Minerals, Rocks, and Fossil Talks. I'm your geology teacher, Jen, and it's time for Monday Musings. We are officially in August, which means we're on to a new topic. We're going to talk about volcanoes. So back in April, we talked a lot about igneous rocks, their origins, how to identify them, all that stuff. This month, we'll be focusing specifically on the volcanoes themselves. Which is great because there are about 44 actively erupting volcanoes right now. Were you expecting that? Probably not. We don't really think about volcanic eruptions like outside of Hawaii and Iceland as occurring very often because we're typically informed about the ones that are, dangerous to people and causing some problems. But there are a lot of actively erupting volcanoes right now, and they're not causing a ton of issue because they're not explosive. Which means we can say that not every eruption is the same. Sometimes you get very runny basalt flows that travel over a great distance. Other times you get spectacular explosions that obliterate the volcano and leave a gaping hole in its midst. So we're going to take a look at what these different types of eruptive materials are and what they leave behind. Basaltic, also known as mafic lava, has a very low viscosity when it first emerges from a volcano because it contains very little silica. And it's ridiculously hot. It can travel very quickly, sometimes over 18 miles per hour or 30 kilometers per hour, and is sometimes found up to 311 miles or 500 kilometers from its source volcano. Basalt lava can travel that far thanks to lava tubes, an insulated tunnel-like conduit in which lava can travel through without the rapid cooling that comes from contact with the Earth's much cooler surface. Lava tubes are created by the rapid cooling of lava, creating a protective crust that insulates the rest of the flow. I have gotten to walk through a lava tube before in northern New Mexico. That was fun. Lots of big, beautiful crystals in there, which you don't normally get in basalt flows. Yeah, cool stuff. I believe this one's on Hawaii. Once the flow cools and solidified, the texture varies based on the movement as it crystallizes. Flows with warm, pasty surfaces wrinkle into smooth, glassy, rope-like ridges called pahoehoe. If lava continues to flow under a hardened surface, breaking it up into rubble, we call it a'a. During the final stages of cooling, lava flows contract and can fracture into hexagonal columns called columnar jointing. You'll find that in loads of places. The most famous one being the Giant's Causeway in Ireland. But you can also find it in Yellowstone. Sometimes you will find holes in basalt. We call these vesicles. This is the top of the lava flow where the gases that were trapped in the melt escaped, like carbon dioxide in a soda bottle. We call this vesicular basalt. Now, andesitic lava flows are more viscous than basaltic, so it doesn't flow as easily. So it builds up in mounds above the vent. They typically don't travel more than 6 miles or 10 kilometers, and due to the slow movement, it has time to solidify, usually forming a broken rubble surface, like this one here. Rhyolitic lava flows are the most viscous because they have the most silica and have the coolest temperatures. They tend to accumulate as lava domes above the vent, and if they flow, they usually don't make it more than a kilometer or a mile or so. Sometimes the lava freezes while still in the vent and then pushes upward as a column-like spire up to 328 feet or 100 meters above the vent. So it's not going very far. Then we have volcanic clastic deposits, which are fragmental igneous material erupted in large quantities. These include pyroclastic debris, which forms when lava is blasted into the air and freezes. This pyroclastic debris changes with the type of eruption. Bet you saw that one coming. So during basaltic eruptions, little pieces of glassy lava and scoria are tossed into the air like water droplets. We call these cinder or lapilli. Now, these lapilli may trail thin strands of lava that can freeze into filaments of glass known as Pele's hair. These lapilli themselves can also freeze into streamlined glassy beads known as Pele's tears. And in case you're wondering, Pele is the Hawaiian goddess of volcanoes, I believe. Yes, the Hawaiian volcano goddess. She has a few other things attached, but for our purposes, that's what we will know her as. Larger fragments from apple to fridge-sized are called volcanic bombs, and they can do some damage. I mean, all of the volcano stuff can do some damage, but these are scary. Now, andesitic and rhyolitic eruptions are much more explosive because they tend to have more volatiles trapped in their viscous melts. Shards of glass formed when extremely tiny droplets of lava spray into the air and freeze instantly fall as ash. Pumice forms when frothy lava freezes and breaks apart. As ash is pulled down by gravity, it can form a fast-moving pyroclastic flow that can reach up to 430 miles per hour or 700 kilometers per hour. Some ash is then lifted up and carried away on the wind to fall hundreds of miles away like a deadly snow. And this is why, if you ever see a volcano movie having people outrun a pyroclastic flow, it's lying to you. You can't. At least, not if it's coming directly at you. If it happens to be going the opposite direction, you're fine. But dude, you can't outrun one. Unconsolidated deposits of any grain size are called tephra. So any volcaniclastics that are unconsolidated, they're not, forming a sheet of rock, they are tephra. When ash is buried and or mixed with lapilli, it becomes tuff. This is the Huckleberry Ridge tuff in Yellowstone. There are two kinds of tuff. There's airfall from ash that fell like snow, like this stuff here, and ignimbrites that form during a pyroclastic flow. And ignimbrites can be so hot that it may weld together into a hardened mass, known as welded tuff. If water mixes with ash and other coarser debris, it may form a deadly slurry called a lahar. And this is one of the main ways that people and towns and villages and things are destroyed by volcanoes. It's through lahars. They cause massive amounts of destruction. Well, thanks for coming to today's lesson, and make sure that you tune in tomorrow for some volcanic trivia. And the question did come from today's lesson, so make sure you paid attention. Fossilization.